Don't ask for authority. Don't ask. Don't ask. Don't ask. It'll make you mad.
You don't pay anything. I thought I did. They probably should have put that short. I don't even know. Is your finger like shorter now?
She actually said with machete. Like she went to grab her machete and like cut her.
Yeah, it's your lab notebook, yeah. Alright, so looking at what's going on today. One, we have our first quiz at the end of class. You guys will be fine, not worried. Your second homework is due Wednesday. It's online. I have your homework to give you back. Don't let me forget to do that. Today we have our first lab. Yay! At 2 o'clock. The room right over here, 200. You want to bring your lab manual, right there, your lab notebook, pen of some sort. If you haven't already done your pre-lab questions, you do them best you can before class in your lab notebook. And it's looking way ahead to Friday, when you're planning for Friday, and you're packing up your stuff in the morning, or your laptop or tablet, smart thing, in your bag. And we're also going to be working in lab and partners, which means often you get to pick your own group, make a group of 3. So, choose wisely. Yeah. And you don't have to work with the person you're seeing next to you here. You can work with whoever you want, just to think you need to be working in partners. Alright, any questions on anything? Yes?
I don't remember if you guys mentioned it last Friday, but is that is the author behind it?
It is. It's not smart enough. No. It's not this Tuesday.
Next Tuesday?
Yeah. Yeah. It's like it's definitely not this week. It is next week. They Can I Kiss You is this week. Isn't it? Hold on, let's see.
Can I Kiss You September 11th?
Yes. Okay, so Can I Kiss You is this Thursday, and the author talk is next Thursday. Yeah.
For our PE package, is there like a counter or something
Yeah, when you go on the Viking web and you go under, I don't think that's what it looks like on your side. Something like either degree planner or required courses, something like, there'll be a counter in there. It'll say how many you've gotten. Pick up. As long as you fill out the little sheet and turn it back in. No. The competition did. So you didn't go. So, that's fine. Yeah. Uh-huh. No, if you have an appointment at 4, then you go instead of 7:30. Alright, next let's talk about fat. Fat, oils, lipids, all the flavor that comes with cooking. No, he doesn't know water. He doesn't have snow water on the cookies, just the other stuff. I have to figure out a way so I don't sit long. I don't want to sit in writing. Alright, fats, oils, lipids. These are the molecules that are essential to cooking and provide the majority of the flavor. These provide tenderness and also provides vitamins. I did not space this out correctly at all. I'm going to continue writing my introduction stuff over here. Continue. Alright, so fats are chemically unlike water. So is water polar, nonpolar, or we have no idea? It is polar, so if fat is unlike water, it's probably nonpolar. That's going to be about the level of trickiness on your quiz, so hopefully everybody feels confident about that. It could be. No, there is bipolar. That's called a zwitterion. There are bipolar things. Does zwitterion? So if you are both polar and nonpolar, you can be a zwitterion. It's a good Scrabble word. It has a Z and a W.
I'll call them
You could. You could. No, I'm terrible at Scrabble. I like under the pressure, I can only come up with like 3 or 4 letter words. Yeah, I'm like, I have all these tiles. I can spell dog, cat, mouse, rat. That's about it. I can't think of anything else. So, I can't get past the animals. So, side note, it's a funny story, reminds me of that. So, when I was in graduate school, one of my other friends was in graduate school, and she was learning to be a clinical psychologist. And it's one of the things, like you do all these different tests, and one of them is a memory test for people with some sort of head injury. So the test question was, I'm going to give you 60 seconds, name as many animals as you can. I freaked out. I named dog, cat, mouse, duck, platypus. That was it. 5 animals in 60 seconds. I'm not good under pressure. So she's like, okay, we'll change it. Name as many people names as you can in a minute. I named 6. I could think of 6 names. I was like, Bob, Julie, Susie. I didn't even use my own name. I could have used my own name. Nothing. I am not designed to work under pressure. Anyway, side note, doesn't really anything to do with anything, but I don't remember things very well. Alright. Alright, so we have fats and oils. That are stored by plants and animals as a concentrated, compact form of energy. Because in general, fat, lipids, whatnot, have twice as many calories as a sugar. That's why it's worth to eat high fat foods if you're counting calories. You count more as your calories than just the sugar. There, so tasty. See? That's what the flavor is. Alright, but on the flip side, lipids also include, because you can think of them as all bad things, but lipids are also does anyone know what beta carotene is most often found in? Carrots, right? The thing that makes it orange. That's technically a fat. It's a beta carotene. It's what makes carrots orange. Vitamin E is technically a fat, and so is cholesterol. No. Yeah, not often found in little Debbie cakes. All right. Okay, I'll go back. All right, so let's talk about how a fat has a structure that's different than water. So fats and oils are called triglycerides. When I say the prefix tri, how many should you think of? 3. So, and glyceride is related to this thing over here, this glycerol. So, and let me do a little definition difference. When I'm saying a fat, that specifically means it is a solid at room temperature. And when I say oil, that means it's a liquid at room temperature. The fats and oils are chemically similar. It's just, when we're talking about terminology, if I'm saying I'm talking about fat, it is like Crisco or lard. Because a fat is a solid at room temperature. When I'm thinking oil, then you're thinking like sunflower oil or vegetable oil or whatnot, right? You can pour it. But they're all in the same category. Butter is a weird thing. So it depends if we're talking butter or margarine. Butter will be a fat, margarine is a hybrid. So we'll talk about it in a little bit. Yeah, butter is all in fat. Alright, so fats and oils are all triglycerides, or a triglyceride. Has 3 fatty acids and 1 glycerol. And so you can't really see in my picture, but I can zoom in some. There we go. Okay. Alright, so this guy is glycerol. So everywhere there's an edge, that means carbon. So it's 3 carbons stuck together. Each carbon has a OH sticking out from it. Then we add to that a fatty acid. The particular example in your picture is stearic acid. It doesn't really matter which one it is. But those two combine together to swap out one fatty acid for each one of these OHs. So now I have the same backbone, but now I have 3 fatty acids stuck onto that glycerol backbone. Yep, they'll pick up some water. Alright, so fatty acids. They have long, what's called a hydrocarbon chain. So this is an abbreviation in words for 2 different elements on our periodic table. Guesses as to which 2 elements? Hydrogen and carbon. Good. So a hydrocarbon is made up of just carbons with hydrogens hanging off the side. Okay. So fatty acids have these long hydrocarbon chains. where the chains are typically 14 to 20 carbons long. So in this case, this particular stearic acid is 16 carbons long, so kind of right in the middle. Okay, let's talk about what everyone talks about all the time without really knowing what they're saying. Saturated and unsaturated fat. Right, this is like real big buzzwords, like, oh, no saturated or no unsaturated fat, whichever way they want to advertise it. So saturated and unsaturated fats have specific chemical meaning to them. Because I'm talking about their chemical structure when I say saturated or unsaturated. So if I have saturated, actually, let's look at the picture first, right? So this one's the saturated one, this one's the unsaturated one. What is the only difference between saturated and unsaturated? 2 hydrogens, right? This one's missing 2. What does it have instead of 2 hydrogens? Yeah, it has a double bond instead of 2 hydrogens. Right, we're looking at that right there, seeing the big difference. So a saturated fat means that the carbons are fully saturated of hydrogen. Right? There's no more space for any more hydrogens. Has as many hydrogens as it can possibly handle. Has 2 on each carbon. Everybody has 2. That's as many as can handle. So if I'm saying unsaturated, it indicates that it is less hydrogens than the other one. So it has 1 or more double bonds. And less than full amount of hydrogen. So why does this matter? Well, it matters, obviously it matters a lot, otherwise I wouldn't bring it up. So, it's a big deal if you're saturated or unsaturated. So, if we look at the saturated one, right, it's a nice straight line, like they all go straight across. Is this one a straight line? And it has like a weird little kink in it, right? That's going to make a big deal. I had to try this. Let me see if I can. Oh, okay, there we go. So if I have the option of stacking saturated fats on each other, right, if I was going to make a big old pile of them, it would look something like that, right? They just lay on top of each other. All right, now I got this guy. I'm gonna try to put another one in there. Do they stack as nicely? Not really. They don't stack. They have that weird kink in them that keeps them from stacking nicely. Big deal chemistry-wise. So. The saturation matters because the double bonded in the unsaturated prevents them from stacking nicely. So the double bond prevents them from stacking well. excellent question. That's my next point. I'll give you a whole ton of examples. You're getting ahead of me. I'll tell you in just a minute. Okay. So if you have anyone actually ever used lard? What would you describe the consistency of lard to be like? It's like Crisco, yeah. Crisco is technically a processed thing, but lard looks the same. So what's it look like? It's white, and what's it done? It's kind of like the consistency of Vaseline, right? It's kind of slick and whatnot. Alright, so lard is pure animal fat. Alright, so if you're thinking of like when you are thinking of a steak and it has all those white pieces of fat in it, if you take all those out, push them all together, you have lard. Right? So, animal fat are about half saturated, half unsaturated. So, right, animal fats are definitely a solid at room temperature. We talk about vegetable fat. This would be sunflower oil, vegetable oil, olive oil. What other kind of vegetable oils are there? Coconut oil. What is the consistency of those guys? Yeah, right. They're like right on the verge. Like coconut oil is like right on the verge of being liquid, but then it's definitely like olive oil, a liquid, right? Vegetable fats are 85% unsaturated. So, in terms of stacking, if they stack really well, like these guys, right, mostly saturated, it's going to be a solid. If vegetable fats are 85% unsaturated, which means they don't stack well, it makes them a liquid. So the amount of saturated to unsaturated influences what state it's in, whether or not it's going to be a solid or a liquid at room temperature. Let's see. Alright, I'll tell you one more fun fact. I'll put it up for you in the corner. Alright, so the stability of fat is also due to saturation. So stability, in other words, how long it lasts before it goes bad. Right, so you could have a jar of lard for forever. It's not going to go bad. I don't know if anyone's ever had a thing of vegetable oil or olive oil or one of those oils. It gets kind of funky after a while. You probably haven't been alive long enough to be sniffing oil. Oh, have you maybe had nuts that have sat around too long, and next time you open them, they smell funky? They go rancid. This is why. So nuts, right, they have that liquidy kind of oil on the top of them. They have some unsaturated oils in them. The unsaturated, because it has this weird kink in it, allows oxygen to get in there. And what does oxygen do? It spoils it, right? It does its oxidation stuff, and it breaks the bond. And when it breaks the bond, it turns from like nice, like tasty fat to weird smelling, makes you want to throw up fat. If you've ever accidentally had a handful of nuts that have gone bad, you'll know it, because your body's going to reject it. Unless you have an ironclad stomach, in which case maybe you're fine. Yeah, yes, I guess if you have the natural peanut butter where like the oil kind of floats to the top, same thing, those go bad faster than regular peanut butter. It's because they oil on top. Oxygen gets in there, starts breaking up all these double bonds. You get short, smelly chains. Alright, so unsaturated fat. Have double bonds that can be broken over time by oxygen. And that's when your stuff goes rancid. I don't think that's peanut butter you have rancid. Something else. Oh, well, we'll get to that. But the complicated answer. Because there is no, because these guys are related in some ways to cholesterol content, which that's like the bigger player in your arteries than actually the fat type. So it depends. I mean, you're probably not going to be drinking a lot of oil, maybe, unless you're doing that weird oil squishy thing in your mouth. It's a trend right now on Facebook.
Is it coconut oil too?
No, coconut oil is way in right now. This is something else. This is where you're supposed to take olive oil, squish it around your mouth, and spit it back out. It's supposed to be healthy for you.
People do that
instead of brushing their teeth, they squish with olive oil. I can't imagine it does anything for you.
Like, supposedly, I read up on it, like, it doesn't actually do that, but they're like, when you drink it, like, you can physically see your cavities get smaller, and your breath is getting more because it doesn't have those things in it. I don't know.
I wouldn't trust it. I mean, yeah. I mean, maybe the idea is like it's kind of like flossing, that you're squishing it through your teeth, and it would hopefully get all those foods. I don't know.
I heard someone, he said coconut oil, you put it around in your mouth for like 10 minutes a day. I was like, no one has time
No one
for
has
that.
10 minutes. I would rather just brush my teeth. Right? How long does it take to brush your teeth? Like 2 minutes?
Apparently you're supposed to brush your teeth for 4 minutes. I tried that the other night. That was the longest 4 minutes of my life.
Does he just drink it? Drink the coconut?
Keeps it out in the microwave.
Does he have any specific reason for doing that?
Said it's good for your brain.
I'll have to read up on that. I won't comment until I know more. That's weird. Alright, so I can do like 2 or 3 more things and we'll make sure you have enough time for your quiz. Alright, hydrogenation and trans fatty acids, another big keyword, right? I think everybody's concerned about their trans fats. Trans fats. What are they saying chemically when we're talking about trans fats? What does that actually mean? I need to get a taller chair because I can't see everybody in the room. I think he's spinning around. I'll split everybody by height. I'll follow the short people in the front. Alright, so here, let's see. Alright, so we had our saturated and unsaturated up here. Saturated fats come in unsaturated fats come in a few different chemical structures. So we have solid fat shortenings, like your Crisco. So solid fat shortenings from that should be seed oils. Alright, so oil so if I have my oil, right, it's 85% unsaturated. If I want to become a solid, like a Crisco, I'm going to have to change it from unsaturated to saturated. Right, because saturated is a solid, unsaturated is a liquid. If I want to make my oil into a solid, I'm going to force it to, I'm going to force some hydrogens on it. I'm going to have to hydrogenate it. Right? Okay. So they're made by changing unsaturated oils into saturated fat. So when we do this, so this is the process of making margarine. Is this process also, because margarine usually comes from the seed of some sort, a seed oil. And so we're going to force our seed oil to become a fat from an oil by going through the process of hydrogenation. So the process of adding those hydrogens to go from unsaturated to saturated is called hydrogenation. So when we force these extra hydrogens on there, not all of the double bonds will take one. Right, so you are forcing extra hydrogens in there. Most of the double bonds will go away and you get extra H's. Some of them just change shape. So here, this is the same picture I had up here under unsaturated. Same shape, right, up and down. This is called a cis fatty acid. Has a shape like this. Makes kind of an angle like that. So when I hydrogenate things, some of the double bonds will go away, but some of the other ones will just swap sides where this H is. So in this, the cis fatty acid, the H is on top and force it to make a peak. In the trans fatty acid, that same H has just flipped sides. It was on top, now it's on the bottom, and now the peak goes away, flattens out. So it was a peak, now it's flat. So chemically, right, it still has a double bond. So if it has a double bond, what kind of fat does it fall into broadly? It's still unsaturated. But does it look like the normal kind of unsaturated? No. Oh, chemically, yes, but shape-wise, no, right? It was a peak and now it's flat. So now, physically, it looks like a regular saturated fat. But shape-wise, it looks, so physically, it looks like saturated fatty acid. Which is where it potentially has some health consequences. Because your body wants to treat it like a saturated fatty acid, because that's what it physically looks like. But chemically, it's like an unsaturated fatty acid. Your body doesn't always know how to process those correctly. So it's getting some mixed messages. It's saying, well, wait a minute, it looks straight. It has this weird double bond in it. I don't really know what to do about that. And so, trans fats have been potentially linked to building up cholesterol in your arteries. Because your body's getting some mixed messages about what's exactly going on there. So when they're advertising that it's trans fat free, they just mean that the stuff in there either is still fully unsaturated, or it's been hydrogenated, but they've taken out anything with a double bond. So it does not mean fat free. That's not what it means. It just means it doesn't have any of this kind of fat. Yeah. That's for next time. We're going to talk about the chemical process, of course, and hydrogen's on there. But it's a chemical process where we can add like hydrogen gas in there and force it to go. But cliffhanger. I will leave you with that. Like on next time's episode, we'll do how does hydrogenation happen and fats and heat. Yeah.
What is the difference between trans fat acid and
Oh, so hydrogenation is the process by which we make trans fatty acids. So we all start off with cis, and if we want to get rid of double bonds, they get hydrogenated, which can then make a trans. We'll talk some more about trans fatty acids, how to cook with fats and oils, and a smidge bit on mayonnaise. Not too much. Yeah? Alright. So I want to make sure you guys have enough time to do the quiz. So I try to always have 10 minutes at the end to do that.